Hi, in the last lecture we have studied how to form a Routh array. Now we will see the Routh stability condition. For a system to be stable, it is necessary and sufficient that each term of first column of Routh array of its characteristic equation should have the same sign. If this condition is not met, then the system is unstable and the number of sign changes in the first column of Routh array corresponds to the number of roots that lie in the right half of S plane. This is the Routh stability condition. We will try to understand this Routh stability criteria for this example. Consider the following characteristic equation: s power 4 plus 8 s cube plus 3 s square plus 16 s plus 1 equal to 0. Okay. Now we will form the Routh array. So the maximum power of s in this characteristic equation is s power 4. So s power 4. The first row should be s power 4. Here s power 4. 4 is even number. So the first row should consist of all the coefficients of even power of s. So s power 4 coefficient is 1, s power 2 coefficient is 3, and s power 0 coefficient is 1. Next row, s cube row, s power 3 row. Here 3 is odd number. So this row should consist of coefficients of s that have odd power. So s cube coefficient is 8 and s power 1 coefficient is 16. Okay. Next you have to calculate s power 2 row. Okay, but before calculating s power 2 row, you can observe that s power 3 row, this row consists of 8 and 16. So this row is multiples of 8. You can divide this complete row by 8 so that the computational work will be simplified. Okay, so if I divide this complete row with 8, then s power 3 row becomes 1 2. I am dividing this s power 3 row by 8. Okay, so I rewrite this s power 4 also here, 1 3 1. Okay, now I will compute s power 2 row. Okay, so here 1 into 3. So 1 into 3 minus, I will change the pen color, 1 into 1 into 2 minus 1 into 2 by this coefficient 1. So it comes as 1 here. Okay, again the second position in s power 2 row. Okay, I will change the pen color. 1 into 1, 1 into 1 minus, here nothing is there, so 0 you can assume, minus 1 into 0, 1 into 0 by again the same 1. So here it comes as 1. Okay. Similarly, calculate s power 1 row. Okay, so s power 1 row, if you calculate, you will get 1. 1 into 2 minus 1 into 1 by 1. So you will get s power 1 row as 1, s power 0 row also 1. Now as per the Routh stability criteria, observe the first column. If you observe the first column of this Routh array, this is first column of Routh array. Okay, now check whether any sign changes are there in this first column. So there are no sign changes. If there are no sign changes, then the system is stable. And all the four roots or four closed loop poles lie in left half of S plane. Left half of S plane. Okay. Now we will try to understand the same concept with one more example. Consider the following characteristic equation. 3s power 4 plus 10s cube plus 5s square plus 5s plus 2 equal to 0. Now the maximum power of this characteristic equation is s power 4. Now this row should consist of coefficients of s that have even power. So s power 4 coefficient is 3, s square coefficient is 5, and s power 0 coefficient, that is constant term, is 2. Next, second row, s cube row, s power 3 row. This 3 is odd number. So you write the coefficients of s that have odd power. S power 3 row 10, and coefficient of s power 1 is 5. Again, if you see here, this s power 3 row, all elements are multiples of 5. So you divide this complete row with 5 so that our computational work will be simplified. So s power 3 row is just 2 and 1. 5 into 2 is 1, 5 into 1 is 5. I divided this s power 3 row with 5. I am rewriting s power 4 row again here. So this is 3, 5, 2. Okay, this is nothing is there. I have written 0. Now calculate s power 2 row. So here 2 into 5 minus 3 into 1, 3 into 1 by 2, this 2. Okay, so you will get 10 minus 3, 7 by 2, that is 3.5 here. Next, calculate the second element in s power 2 row. Same logic. 2 into 2 minus 3 into 0 by 2, this 2 again. Okay, so you will get 2. Again calculate s power 1. So again here I will change the pen color. 3.5 into 1, 3.5 into 1 minus 2 into 2, 2 into 2 by 3.5. So it comes as minus 0.5 by 3.5. Okay, again this coefficient second term is 0. S power 0 row is 2. Now observe the first column in Routh Hurwitz. Here this is the first column of Routh Hurwitz. Now calculate the number of sign changes. Here this is plus 3, plus 2, plus 3.5, and minus 0.5 by 3.5, and this is plus 2. So there are two sign changes, plus 2 minus and minus 2 plus. So the number of sign changes equal to 2. So that means out of 4 roots, 2 roots lie in right half of S plane and 2 in left half of S plane. Since 2 roots are present in right half of S plane, the system is unstable. Okay, so like this we have to determine the stability of any system using Routh Hurwitz criteria. Routh Hurwitz criteria will not give the exact location of poles. It only gives the distribution of poles, which is helpful to comment on the stability of the system. Thank you.